Okay. So transformations. All right. What is a transformation? Well, let's define it here. And we'll kind of give it a bit of a mathematical definition. Okay, a transformation is a function that changes the position, shape, and or size of a figure. Okay, so it might just change the position, it might just change the shape, or the transformation might just change the size of the figure, or it could do any combination of those three. Okay, it could change the position and the shape, it could change the shape and the size, it could change the position and the size, or it could change all three. Okay, and that's a transformation. Now, you guys have already talked about transformations before. In fact, I know you dealt with them back in like Common Core Algebra 1, right, where you would do transformations to functions, right? So you'd maybe take like a parabola, x squared, and you'd maybe shift it left or shift it right or shift it up or shift it down. Do you guys remember doing that kind of stuff? Okay, so we're going to deal with that too, but not so much dealing with actual like functions like that. We're going to do it with shapes, okay? And so you don't have to worry too much about like that was more with functions and things. We're going to worry about mostly with just shapes, okay? It's like triangles, quadrilaterals, you know, sometimes segments, okay? And I don't think you used this kind of I guess way of writing things, okay? So for example, we talk about the original, okay? The original figure, that is also known as the preimage, which really annoys me that we call it the preimage, and I'll kind of explain why here in a second. But we start with like an original shape or object, also sometimes called the preimage, right? It undergoes some sort of transformation. Some transformations we have names for, some transformations we don't really have names for. And we'll take a look at some example of that here. And then when you transform it, the original now becomes the image. Okay? So for example, if your original had like a point P in it, okay, if your original had like a point P in it, for example, we denote the transformed version of P as P still, but we put a little apostrophe. Okay, so this P with the apostrophe means that it was transformed from the point P there. And we read this new point P as P prime. Okay, so Optimus Prime is a transformer. P prime is a transformed point P. Okay? And if you undergo multiple transformations, so let's say we then transform P prime, we would call the next point P prime prime. And if you transform it again, it'd be P prime prime prime. And if you transform it again, well, you get the idea, right? Okay. I think it kind of like stops at some point though, and there must be some other way to write it because it would be kind of a hassle if you did 10 transformations to say P prime 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 prime. You know, too much. Okay. So anyway, the main types of transformations you guys are familiar with, hopefully from like elementary school probably is when you first learned about these, right? You talked about the slide, you talked about the flip, you talked about the turn. All right, well, we're not going to use those words. Okay? We're going to use fancier math words. So, for example, instead of using flip, we're going to call that a reflection. That's right. Okay, for a turn, we won't call it a turn, we're going to call it a rotation. And then we're not going to call it a slide, we're going to call it a this is harder, translation. It's called a translation. The other two, it's like, yeah, I can see that. And then translation, it's like, how does that relate to a slide? Reflection, okay, yeah, that's basically what a flip is, right? Rotation, yeah, okay, it turns, right? But translation, it's like, don't know. And then off to the side here, we're going to talk about one other one that you maybe didn't have a name for. We're going to talk about dilations. Okay, as well, dilation is going to be another transformation that we're going to name. Now, what does it mean? What does dilation mean? Yeah. Tanner.
Making objects bigger or smaller?
Yeah, very good. So very important that you said that too. So dilation does not mean always that something gets bigger, and it doesn't always mean something gets smaller, right? Just it means it changes its size, right? Either bigger or smaller is a dilation, right? So you guys go to like the eye doctor, right? And they put those like drops in your eyes to make your pupils dilated, and then you have like a tough time seeing afterwards. Everything's fuzzy because I guess they want to like look into your eyes or whatever. So stuff like that. Or if you get a concussion, right? They check to see if your pupils have dilated. That is, they've changed size. Or not, okay? That's kind of an indication. So, okay. So what we're going to do here is just we're going to run through some examples and kind of identify some transformations, okay? So our directions here are to perform the indicated transformation okay, and identify it. I'm just going to use ID though. Identify it. Okay. So one way we're going to do that, one way we're going to be like told how to do a transformation, okay, is to do something like this. We'll be given information about the original or pre-image. By the way, the reason why the word pre-image annoys me is because I feel like original is a better word because you have the original, right? That's what you start with, and then it's the image. That's like you do something to the original and you get the image. But to call something a pre-image, it's like, I don't know, the word pre-image makes me think that something's already been done to it, or it just doesn't, I don't know, it doesn't fit right. I don't like how but it's used quite a bit. In fact, it's used in, some tests and stuff like that. So, but anyway, pre-image is the same thing as original. Okay, and we're going to do this in the coordinate plane. So here's one way we can kind of indicate a transformation. For example, we'll start with a generic point xy. Okay, so this will be given to us. And then the arrow is going to mean we're going to transform that point. And then this is going to tell us how we transform it. Okay, and thus create an image point. Okay, so you can kind of see there that in this transformation, we're told to take any coordinate xy and to transform it by taking our x-coordinate and subtracting 4, and that's our new x-coordinate. And then our new y-coordinate is found by taking that old y-coordinate and subtracting 3. Okay, so the new x-coordinate is taking the old x-coordinate, subtracting 4. The new y-coordinate is found by taking the old y-coordinate and subtracting 3. So let's actually put some points in here and see this. So let's see. We can start with some points. Let's say I got A, B, C. Okay, and A will have coordinates 0, 4, B will have coordinates 3, 0, and C will have coordinates 0, 0. Okay. And so these all transform then, A prime, B prime, C prime. Okay. And so to find A prime's coordinate, we just take A, right? So A has x coordinate of 0 minus 4, that gives us negative 4, right? And then A prime's y coordinate is going to take the old y, 4, and subtract 3, so 1. Okay, so there it is. Same deal here. B, 3 take away 4, so negative 1. 0 take away 3, so negative 3. And then C prime is what? Negative 4, negative 3. Okay, so there's the transformation. All right. Can anyone identify what kind of transformation this might be based on what we have here? Might be hard to see, but Maria, what do you want to say? Not sure? Okay, no? Go ahead, Patrick. Maybe a translation? Is that what you're going to say? Hunter is a translation. Anyone else want to say something different? All right, so let's see. So we actually can, actually see this visually, right, by graphing it. That's a nice thing. So let's go ahead and just sketch a coordinate plane over here real quick. Okay. When it comes to sketching coordinate planes for me, guys, I don't require you to like label. I mean, I would ask that you label the x and the y coordinate, but that's not totally necessary either. I'll just assume it's an x and y coordinate. I'm not even going to make you label numbers on the axis if you don't want to. Okay. Now here's the one exception to that. If you're not counting by ones, you need to label that. Okay, so for example, if you're counting by twos, you need to put a 2 down there, okay, or something like that to show that you're counting by twos. If you don't label this, I'm going to assume you're counting by ones. Okay, so that's the only thing I'm going to say about that. So let's plot the original. So A has coordinates 0, 4. So 1, 2, 3, 4. There's point A. B has coordinates 3, 0. There's B. C has coordinates 0, 0 at the origin. Oops, and I called it, and I should have called it C. Okay. And so our shape is kind of like right along here, buttoned up against the axis. Okay, there's our triangle. Okay. And now we'll plot our new points. So that's here, negative 4, 1. And that was A prime. Negative 1, negative 3. That is B prime. And then C prime is negative 4, negative 3. And again, connect the dots. Yeah. Okay. And so what kind of transformation does it turn out to be? What kind of transformation is this? Anybody? Is it a dilation? No. Right? What is it? Translation. That's right. It's a translation. Okay, it's a slide. And specifically, how does it translate? For example, to get from A to A prime, what do we have to do? Yeah, Tanner.
It translates from 4 to the left and down 3.
Down 3, or left 4 and down 3. Exactly right. If you go from A to A prime, you go left 4 and down 3. From B to B prime is the same thing, right? Left 1, 2, 3, 4, down 1, 2, 3, and C to C prime is left 1, 2, 3, 4, down 1, 2, 3. Okay? So, where can we kind of see that indicated that that's going to happen elsewhere here on the paper? So besides just counting it, where else can we see that's happening? Where else can we see that that is happening here on the paper? Where else are we told that? Hunter.
Oh, like the image, like that thing.
Yeah, this thing right here. So this, by the way, is called coordinate notation. Okay, for the transformation. This is coordinate notation. This is a way to describe a transformation in coordinate notation. Okay, so this is how we can show a transformation in coordinate notation. And that's exactly right. It's kind of told to us right there. The x coordinate you're subtracting 4, so it makes sense we're going to go left 4. The y coordinate you're subtracting 3, so it makes sense we'll go down 3. Okay, and that's exactly what it is. So it's a translation. Left 4 and down 3. Okay. All right, let's try another one here. So let's see. Okay, I'll give us another coordinate notation. So we'll start with xy, and that's going to go to negative x, comma y. Okay? So let's again kind of think about what's happening here. From our original to our image, or from our pre-image to our image, okay, what's staying the same? The y. So the y coordinate's staying the same. So that means our point won't move which direction? If our y stays the same, that means we're not going to move which direction? If our y coordinate's staying the same, that means our image will not move which direction? Up or down. That's right. It can't move up or down, right? Because it's just going to stay the same y. But x then is changing to negative x. That means we're going to be moving like potentially left or even right here too, depending. Okay? So let's kind of take a look here. I'm going to do it in a bit of a different way. So let's see. I'm going to start with All right, we'll just put our points down. So we'll do R, S, and T here. Okay. So R will give coordinates of -4, 3. S will give coordinates -1, 3, and T will give coordinates -4, 1. Okay. Okay, so let's see here. Let's do the transformations. So then, Shannon, what will be our new coordinate for R prime? What will it be? If we take xy and it becomes -xy, what's, yeah, +4, and then 3 stays the same. Exactly right, +4, because it's a -4, so it becomes +4 there. Okay, that's right. Let's go to, all right, Michael, what about S? What's S going to become, Michael?
1, 3.
Yeah, +1, 3, exactly, or just 1, 3, that's really okay. I was just emphasizing it. Okay, you were right, though. Okay, and then Mary, how about letter T? What's that going to be? What's point T prime going to be?
4, 1.
Yep, again, 4, 1. Okay. So yeah, let's go over here and sketch that real quick. Anyone think they have an idea about what this is going to be? Yeah, Evan, what do you say? A reflection, okay. We'll see here. Okay, so let's see here. -4, 3. -1, 3. -4, 1. Okay, so there's RST. Okay, so plot R prime, S prime, T prime. So 4, 3. Okay. So sure enough, it is a reflection. Okay. Can we be any more specific than that? Can we give a little bit more information rather than just saying reflection? Drew, what do you want to say?
A reflection across the line.
Yeah, there you go. Exactly right. It's a reflection over the y-axis. Okay, and when we look more in depth at reflections, okay, we're going to be more specific because whenever we do a reflection, okay, in fact, that's what you're going to be looking at tomorrow, I believe, is reflections. Okay, we're going to be using the mirrors again, so apologies to Michael and Elizabeth, although she's not here to hear it. But we're going to be using the mirrors and also patty paper as well, which is up there in the green package. And don't worry, in the video tomorrow, I tell you to go ahead and grab those two things at the start of class. So, yeah, you won't be like hopefully jumping up out of your seats and then running over there to grab it while I'm still talking and stuff. Okay, we're going to be looking at those tomorrow. And in fact, reflections, you generally have this line of reflection, okay, that you reflect over whenever you're reflecting. And there's some interesting relationships that happen with that line of reflection and then the original and the pre-image. There's a relationship there too. That we'll look at more in depth tomorrow, okay, when I'm not here. All right, so flip that over then. Let's see here. We're going to do two more. Okay, dos más. All right. So let me see. I'm going to zoom down. It's just going to give us some bearings here. Okay. So now we're going to take xy in this coordinate notation, and we're going to see what happens when we do -y, x. Okay. So this is a bit of a strange transformation. So we're taking our original point xy and the new point, the transform point, will put the old y coordinate as the new x coordinate, the opposite of the old y coordinate. Okay, so it takes the old y coordinate and makes it now the x coordinate, but it's the opposite of that. Okay, and then the old x coordinate now becomes the new y coordinate, exactly the same. Okay, so if we do that transformation here to these points A, B, and C, Okay. Julia, what is A prime going to become then? So 1, 2 is the original. What is A prime then?
-2, 1.
Yeah, you got it. Good job. -2, 1. Well done. Okay. And then how about, let's see, I already talked to Zishan earlier. I don't know if I want to put him on the spot again. Goodness, we this new. All right. So how about Julie then? What about B? What would B prime be, Julie?
-2, 4.
Yeah, very good. Yeah, -2, 4. Okay. And then C prime will go to Patrick. What would C prime be there, Patrick?
-2, 3.
2, 3. Very good. Yep. Watch those negatives there. That's right. 2, 3. Okay, so let's sketch that real quick. All right. And anyone want to take a guess what this one's going to be? A what? Rotation. Yeah, it's like, come on, Mr. Whitmire, we've been through math classes and education long enough. When you give us 3 options and you've already done 2 of them, then you're pretty much going to leave 1 more there, okay, for us to, it has to be that one, right? Process elimination. So
the next one's going to be dilation.
We'll see, you know. I don't know, Evan. We'll see. You could be a teacher one day, maybe. Okay, and then 3, -2. Oops, I can't count. Yeah, 3, -2, that was right. Okay. Okay, so there's C, and okay, A, B, C, and then we'll go ahead and plot A prime, B prime, C prime. Two, 3. Okay. And sure enough, it is a rotation. But again, can we be more specific? Can we be more specific here? So I'm going to give you guys, let me give you guys a chance to look at this. So we definitely can agree it's a rotation. Okay. Can we say what direction? Because rotations can go 2 different directions, right? So what direction is this rotation? So we'll normally use like counterclockwise or clockwise. So if this black one was our original, red one's the image, what type of rotation is that? So could be counterclockwise, but
Could it be either though? Because if
true.
you go one way or the other way.
That's true, exactly right. I was just thinking that myself. I was like, wait a minute, you could actually do both there. So never mind. I apologize. Okay, yes. The shortest direction though would be which one? Counterclockwise, right? Okay, the shortest direction is counterclockwise. Okay. All right, and so that's true. Also, rotations normally have a center, a point that you're rotating about. So what's the point we're rotating about here? It's the origin, exactly right. And we're going to keep it that way too. It gets really complicated if you try to rotate about other points that aren't on the the origin. At least the coordinate notation gets kind of tricky. You can do it by hand, I guess, but the actual coordinate notation part gets kind of tricky to do. All right, so yes, it's about the origin. So it's a rotation of, how many degrees does that look like? And let's do the counterclockwise direction. So I'll put CCW for counterclockwise about the origin. So what degree? Yeah, what do you say?
90.
Is it 90? Okay, so, well, let's see here. So if we're going about the origin, let's see, if I could kind of create one side of my angle by going from A to the origin, and I can create the other side of my angle by going from A prime to the origin. And that looks pretty close to 90 degrees. In fact, if I took like a corner of my paper here and stuck that in there, that looks pretty close to 90 degrees, doesn't it? How can we determine whether that's exactly 90 degrees or not, though? If this was 90 degrees, that means this side and this side would be perpendicular, right? This side right here from the origin to A should be perpendicular from the origin to A prime. And let's see here. How do we just talked about perpendicular lines, right? How are the slopes of perpendicular lines related? Opposite reciprocal. So let's find the slope here. What's the slope from the origin to A? Well, we have to go up 2, right 1. So from the origin to A, it's 2 over 1. And what's the slope from A prime to the origin? Yeah, negative 1/2. So are they perpendicular? Yeah, they are. That's a 90-degree angle right there. So good eye. That's exactly right. It's 90 degrees. It's a rotation of 90 degrees counterclockwise about the origin. Okay. And again, when we get into rotations, we'll talk more about that. We're going to focus mostly on rotating in the coordinate plane. We're going to focus mostly on rotating 90 degrees, 180 degrees, and 270 degrees. Okay, because those are, again, they have like nice matching. They have nice matching coordinate notations there. All right, one more here. I'm going to have you guys try. Evan thinks he's already got it figured out. We'll see, Evan. We'll see. Okay. So I'm going to give you this transformation here. xy goes to 2x comma y. And I'll give you these points. J has coordinates 1, 1. K has coordinates 2, negative 1. And L has coordinates negative 2, negative 2. So go ahead, find their transform points, and then graph. Okay, to see if you can figure out what it's going to be. Okay. I'm going to do it real quick too, and then I'll come around and take a look. That's supposed to be a negative 1 there. Sorry, not a 4. So that's why it's 1, 1, 2, negative 1, and then negative 2, negative 2. There for the points. Sorry, my handwriting.
So it's 2 times 2.
Uh-huh.
And then 4.
So 4 is the x coordinate.
Yeah, 2 times 2 would be negative 4.
Yeah, negative 4. That's it.
Sorry.
Do the same thing. Yeah, I'm sorry. Okay. So you still would end up with like a similar result.
Yeah.
So, I mean, yeah. And Tanner, you're, I mean, you feel good. Don't worry about it. Just a similar result there. Okay, that's all right. Yeah, no worries. Yeah. All right, so I guess I'm mostly there, just about done, and I didn't do a great job, very neat there, but there it is. Okay. And so it turns out, though, this is not a dilation. It's not a dilation. Okay? Because for a dilation to be a dilation, the only thing that changes is the size of the shape. Okay, the only thing that changes in the dilation should be the size. So, for example, when you say your pupils are dilated, okay, if your pupils are dilated, they still stay circles. Okay, they don't like changing to stars or triangles or something like that. They stay circles. Okay, so this triangle JKL, okay, if it was being dilated, it would be still the same shape triangle. It would just be either a larger triangle or a smaller triangle. Okay, that's not what happened here though with JKL. All right, it didn't just like blow up or just didn't shrink. What actually kind of happened here? How could we maybe describe this transformation? What would you say? Yeah, Melissa?
It's like stretch.
Yeah, and stretch. And in fact, could you say by how much did it stretch? Yeah, 2 times, right? Exactly right. It stretched kind of like twice, okay? It stretched out twice because, again, we took all of our x-coordinates and multiplied by 2. Okay, and so our x-coordinate stretched out, but the y-coordinate stayed the same. So we just kind of like stretched it, okay? So something you can maybe do, when you're like MS Paint or something like that, and you're playing around, and you're like, oh, I need to adjust this picture. You stretch it out some, right? It would have to also stretch vertically by the same amount, so we would need a 2 in front of the y there to then create an actual dilation. Okay? With the way that's written there, it's not a dilation, but we can still describe it, right? It's stretched to be larger, okay? Stretched horizontally, we would say. So horizontal stretch. So it's actually not a dilation. So unfortunately, Evan, I kind of left you high and dry here. We're not going to look at a dilation, okay? But there you go. So this transformation doesn't really have a name. So here's an example of a transformation that doesn't have a name. But it's a thing we can do. It's a thing we can do. Okay? Now, you'll notice then, right, a translation. Did the size or the shape of size or shape of our figure change?
Yeah.
No, right? The triangle stay the same size and stay the same shape, right? How about for the reflection there? Did it change? No. How about for the rotation? Did it change? Yeah, no. Okay, and so we classify those 3, okay, uniquely as rigid motions, or just a rigid motion transformation. Okay, and this is the last little bit here. Okay. Also known as, in some circles, an isometry. I-S-O-M-E-T-R-Y, isometry. Okay, and rigid motion transformations are when sides, angles, and shape stay the same. Okay, rigid motion transformation is when sides, angles, and shapes stay the same. So that's like your reflections, your translations, and your rotations. Okay, non-rigid right, it's pretty obvious. It's just, if it's not rigid, then it's non-rigid, okay? So that's like your side, and there's no special name for that. Just sides, angles, or shape change. Okay, and a prime example of that is like dilation. Okay, and others, but they're not named necessarily. Okay. So that last transformation that we did there, is it rigid motion? And the answer is right, no, it's not, because it stretched it. It changed the shape, changed the size, changed some of the angles too. In fact, all 3 things changed. All 3 of those things changed. Okay. So, non-rigid motion, not an isometry. Okay? So there is that. Let's see here, I think that's all I wanted to look at. Okay. Very good. So we'll take a look then. Let me give you guys your assignment here. We'll give you guys 25 minutes and we'll have you go over this. Okay, so the paper I'm about to hand out, I'm just going to give you the assignments up here. It's not all of them. Okay, so I'm going to have you do, let's see here, numbers 5 through 20. Oops, sorry, no, 5 to 25. And don't worry, that sounds like a lot, but it's going to go super quick. 32 and 34, 35. Okay, so let me give you guys those. I'll go ahead and cut the video here too.
I'm going down to the copy room real quick. I'm hearing about this next class.
Got it. Go in swinging.